Okay, so welcome to all of you. Now, in the last session, we have seen the general quadrature formula. Now we'll see the trapezoidal rule. Okay, so for trapezoidal rule for the numerical integration. Okay, so now we have to evaluate this integration with the help of the trapezoidal rule. So what we have to do? We have to derive the trapezoidal rule first. Okay, so that means what you want to evaluate this integration from a to b f of x. For that, what we will do? We will divide the interval AB, this is AB, into n equal sub interval each of length h, such as a is equal to x naught, so x1, x2, this xn, where xn is what? x naught plus xn. So we have the general quadrature formula. So the general quadrature formula is this. Okay, so this is what h is. Okay, so first put n is equal to 1. Put n is equal to 1. That means what? The interval what we get there only? The interval what? x naught, x1. That means we get only y naught, y1 only. So we put n is equal to 1. So what do we get then? So this is what? Integration from x naught to xn f of x dx is equal to, okay, x naught. So then this is what? H. So n means this is y naught plus 1 half then y naught. So I have the value of y naught and y1. So what we will do now here? So I will take this h by 2 common here, so that this will become twice y naught plus, and then y naught is what? y1 minus y naught. Then y naught means what? y1 minus y2. y1 y naught y1 minus y naught. So this is what then? h by 2. So if you simplify this, then this is y naught plus y1. This is y naught plus y1. And for this one, I will do this one for x naught to x1 to x2 now. x0 to x2. Then this is what? F of x dx. Then this is h. Then this is what? Your n. This will be y1. Your y naught will be what? Initial value will be the y1, because what? y1, y2. Initial value is y1. So plus 1 half, then y1. Okay. So now we take h by 2 common. So this is what? Twice y1. See, this is what? H by 2 are common. That means I have to multiply by 2 to all the entries or to all the terms. Okay. We are taking h by 2 1 by 2 common. That means what? We have to multiply by 2. So 2y1 plus then y1 plus then y1. But then y1 is what? y2 minus y1. So this is 1 half y1 minus y1 plus y2. y1 plus y2. Now we'll do this for x2 to x3 f of x dx. x2 to x3 f of x dx is what then? Then this is what? H. Now this will be your y2 now. This is what? x2, x3. That means y2 and y3 we have the value. So you instead of y0, that is y2 plus 1 half then y2. Again I will take this common. So what I get then? This is what? Twice y2 minus plus then y2. Then y2 means what? y3 minus y2. So this is equal to then what? 1 half. This 1 half, not h by 2 now. This h by 2 y2 plus y3. Okay. So dot. I will do this for xn minus 1 to xn f of x dx. Is equal to what then? H. This is what? yn minus 1 plus 1 half then yn plus then y. Same thing here. I will take h by 2 common. So then this is what? Twice yn minus 1 plus yn minus 1. So this is what? h by 2 yn minus 1 plus yn. Okay. So what I will do? I will take this as a 1. Okay. No need to write this. Okay. So okay. So therefore, integration from a to b f of x dx is equal to integration from x a is equal to x naught to x1 f of x dx plus x1 to x2 f of x dx plus x2 to x3 f of x dx plus dot 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 plus xn minus 1 to xn, this is b f of x dx. Okay, so we know this is what, so the finite integration, this is rule for the finite x0 to x, this is a to x1 x1 x2 x2 x3 and so on, right? And this is last piece. Okay, so now we put this value here, this is what, h by 2, h by 2. What is the value of this one? Y0 plus y1, y0 plus y1 plus h by 2, y1 plus y2 plus h by 2, y2 plus y3 plus dot 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 plus h by 2, yn minus 1 plus yn. Okay, now see here, h by 2 is everywhere, so I will take the h by 2 common. Now see, y0 and this yn is not repeated, so what I do, I will write this as y0 plus yn, because they are not repeated, so they are the single here, so we take the addition of this. Other values, y1 is y1, y2 y2, y3 y3, yn minus 1 is here, y1 minus 1. Okay, so that they are the double, so for addition they become 2, then this is what, y2 plus y3 plus y4 plus yn minus 1. Okay, and this is called trapezoidal rule. Trapezoidal rule for numerical integration. So you have to remember this, what, integration from a to b, f of x dx is this. This is the formula. This is the formula. What? H by 2, yn plus y0 plus yn, that means what? The first and last point, and all the middle values are, you have to take the sum and you have to take the twice of that one. So h by 2 is there now. Okay. So this is the Simpson's rule, this is the trapezoidal rule for the numerical integration. Okay, so you should remember this as the formula. This formula is very important. If you forget the formula, you cannot solve, you are not able to solve the problems. Okay, so if you want to solve the problem, you should remember this formula. This is very easy now. H by 2, y0 plus y plus 2 times this. Okay, so how to solve the problems with the help of the trapezoidal rule, with the help of the given data. So now here for this is the general formula. So for if you are solving the problem on trapezoidal rule, you have to write, this is what, you have to write a particular value. This is y0 plus whatever this y5. The last point is y5. Then this is y0 to y5. Then this is 2 y2 y3 y4 only. You have to close the bracket only. Don't write the general formula while solving the problem. Okay. So when we are solving the problem, so write the correct formula. That means what, write the yn and all those things. Okay. So that we will see later on, how to solve the problems with the help of the trapezoidal rule. Okay, so this is the trapezoidal rule. I hope that you understand how to derive the trapezoidal rule in the numerical with the help of the general quadrature formula. Right, the general quadrature formula plays a very important role to derive the trapezoidal rule. So you should remember the general quadrature formula. This general quadrature formula is very important. Right. So if you remember the general quadrature formula, so why here we are not taking this del square y0? Because we have only the two values. Okay, that means what, if the first difference is constant and the second difference is 0. So afterward they are the 0 now here. Afterward they are the 0. So therefore we have taken only the del y0 here. Okay, so because what, we have only the two values, y0 and y1. We have the, for n is equal to 1. That means what, we have divided the interval into one equal. That means the interval is same now here, x0 to x1 only. Your xn is your x1 and that is the b now. Okay, so therefore this is what, del square y0 del cube y0 we have taken 0 here because your n is equal to 1. Okay, so I hope that you understand how to derive the trapezoidal rule for the numerical integration. Okay, so now we'll stop here. Thank you.